Hello friends, welcome to the video lecture series of Engineering Mathematics 2. In last video, we discussed what are the preliminaries of the solid geometry, how the solid geometry is useful in engineering. In this video, we are going to discuss short answer question on the important structure of three-dimensional geometry, that is a sphere. The sphere is the three-dimensional counterpart of the circle. Circle is nothing but the locus of the point from the fixed point in two-dimensional plane. Sphere is the locus of the point from the fixed point in three-dimensional plane. Is a sphere. Now, what is center radius form of the sphere? If center of the sphere is given, the radius of the sphere is given to you. ABC are the center and R is the radius. Then this is center radius. If center of the sphere is 1, 2, 3 and radius of the sphere is 4, then how to write equation of sphere? Equation of sphere, you can directly write x minus x coordinate of the center, y minus y coordinate of the center and its square, z minus z coordinate of the center and its square is equal to radius square. Okay, this is equation of the sphere. Okay, this type of question may be asked in the examination. Now the general form of the sphere, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals 0. Okay, this is general form of the sphere, and here the center of the sphere you can easily find from it, that is minus u, minus v and minus w, and radius of the sphere you can find out using the formula u square plus v square plus w square minus of v. Now the equation of sphere passes through the origin. If equation of the sphere, if any structure passes through the origin, equation of that structure is free from the constant. Therefore, the equation of the sphere I am writing x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is not there, equal to 0. Now diameter form. If this is the center of the sphere and these are the end points of the diameter, and I am drawing the diameter in this way. The AB is the diameter, and the coordinates of A and B are given to you. The coordinates of A are x1, y1, z1, and coordinates of B, point B, x2, y2, z2. Okay, these are the two end points of the diameter, you can say. Then how do you write equation of the sphere? The equation of the sphere, you may remember this as a formula also. This may be asked as an MCQ. Equation of sphere is x minus x1, x minus x2 plus y minus y1 into y minus y2, z minus z1 into z minus z. Okay, this is the equation of sphere. The MCQ may be asked like this. Find the equation of sphere whose end points of the diameter are this way. Means end points of the diameters are given to you. Here in this case particularly, the coordinates of A, coordinates of B are given. Then how do you find out the equation of sphere? Use this formula to find out equation of sphere. Then equation of sphere will be x minus x1, this is x1, x minus x2 plus y minus y1, y minus y2, z minus z1 into z minus z2 equal to 0. So this is equation of sphere when end points of the diameter are given to you. So you may expand it. You may have the multiplication of these two brackets, multiplication of these two and multiplication of these two, and you may solve it further. Now, find the center and radius of the sphere. This type of MCQ may be asked in examination. The center and radius of the sphere I am going to find out. So first of all, by procedure I tell you, or you can directly find out the center and radius also. This given equation of the sphere is in the standard form. I am equating this with 2wz plus d equal to 0. Okay, this is general equation of the sphere in standard form. Okay, general equation of this is general equation of the sphere in standard form. Here the coefficient of x is 2u, coefficient of y is 2b, coefficient of z is 2w, and constant coefficient is this one. Here 2u is equal to 6. This means u equal to 3. 2b equal to minus 4. This means b equal to minus 2. 2w equal to 2w equals 8. Therefore w equal to 4. And value of d is minus 10. So how do you find out center? The center of the sphere is minus u minus v minus w, and putting value here, u is 3, v is minus 2, minus minus will be plus then, and w is 4. So this is the center of the sphere. And radius of the sphere, the formula for radius of the sphere, u square plus v square plus w square minus d, putting value of u, v, w and d, u square is minus 3 square or 3 square you can say, v square minus 2 square, w square is 4 square, and minus of d, and this is equal to under root of, this is 9 plus 4 plus 16, minus of d is minus minus, here plus, you can write like this, minus of minus 10, and this is 20, 29 and under root of 39. The under root of 39 is the radius of this sphere. And you can find out center directly also. How do you find out center directly? See, coefficient of x is 6, half of 6 is 3, and change the sign of 3 is minus 3 here. See, coefficient of y is minus 4, half of minus 4 is minus 2, and then change the sign, it will be plus 2. Coefficient of z is 8, make half of it is 4, and change the sign. In this way you can directly write the center, and radius you can directly write the square of first element is 9, square of second element is 4, square of third element is 16, minus of d, the d is minus 10 here, and minus minus will be plus, this is 20, 29, and root of 39 is the radius of the sphere. Here I am going to find out center of the sphere directly now. The center of the sphere, coefficient of x is 2, half of 2 is 1, and change the sign. Coefficient of y is minus 4, half of minus 4 is minus 2, and change the sign. Coefficient of z is minus 6, half of it is minus 3, and change the sign. This is the center. And how do you find out the radius of the sphere? Radius of the sphere directly, square of minus 1 is 1, square of 2 is 4, square of 3 is 9, minus of d is 5 here, and under root of this 5 and 5 goes away, root of 9, and root of 9 is 3, 3 is radius of this sphere. Okay, root of 9 is plus minus 3, but radius is always positive, therefore only plus 3 I have taken. Now, and this type of problems may be asked as an MCQ. The next problem, equation of the sphere with the center and radius. Equation of the sphere and with the center and radius, how do you write? Center is given to you, and the radius is also given to you. The center radius form we will use. Okay, this we have done previously. This is the equation of sphere. Equation of sphere is this one. You may expand it. You may have the square of these brackets and you may solve it further. So the next point is the equation of tangent plane. The tangent plane is that plane which touches the sphere at the single point. Which at point A, this plane is going to touch this sphere. This is the center of the sphere. I am calling it as C, center of the sphere, and P be any point on the plane. What is equation of plane? X x1 plus y y1 plus z z1 plus u times x plus x1, v times y plus y1, w times z plus z1 plus d equals c. And what are x1 y1 z1? The x1 y1 z1 are the point of contact. x1 y1 z1 are the coordinates of the point A, and u v w are the coefficients of x, coefficients of y and coefficients of z in equation of the sphere. Now the problem on this, equation of tangent plane to the sphere, equation of sphere is given, and tangent plane at this point I want. For equation of tangent plane, what I want? x1 y1 z1. The x1 is 1, y1 is 2 and z1 is minus 1. u v w are also required. Then what is 2u here? 2u is a coefficient of x, which is 1. Therefore, u is 1 by 2. 2v is coefficient of y, which is minus 2 here, and value of v is minus 1. 2w is a coefficient of z in equation of sphere, which is 3, and w is 3 by 2. And d is a constant coefficient in equation of sphere, which is 4. These values of x1, y1, z1, u, v, w and d get put here in this equation. Okay, I am calling this as equation 1. The equation 1 employs x x1, x x1, y y1, z z1 plus u times x plus x1. What is u here? U is 1 by 2. X plus x1, v is minus 1. Y plus y1, w, z plus z1. So this is the equation of the tangent plane. So you can solve it for one more step. X plus y minus z. Here I have written x plus y minus z. Then x by 2 plus 1. X by 2 plus 1 by 2. Here minus y minus 2. Here 3z by 2 minus 3 by 2 is equal to 0. This is the equation of tangent plane. So you may solve it further if you want. This 2 is present in the denominator. I am going to multiply it by 2. If you multiply it by 2, what will happen? 2x plus 2y minus 2z plus x plus 1 minus 2y minus 4. I am multiplying it by 2. I am multiplying each and every element by 0 multiplied by 2 like this. Okay. Now 2x plus x is 3x, 2y minus 2y minus 2z plus 3z is z. Then constant coefficient 1 minus 3, 1 minus 4 minus 3 minus 3 minus 3 minus 6. This is equal to 0. Okay, this is the equation of tangent plane. Next, point of contact of the plane, and that plane is a tangent plane. Equation of tangent plane given to you. Equation of this tangent plane is given 2x minus 2y plus z plus 12 equal to 0. Okay, this minus 12 I have shifted on the left hand side. Equation of tangent plane is available. And to the sphere, whose radius is 3. The radius of this sphere is given, which is 3. This point is C, this point is A. CA is given to you. Center of the sphere is also given, 1, 2, minus 1. Point of contact of the plane means I want coordinates of the A I want. So how do you find out the coordinates of A? See here, the coordinates of A be x, y, z. This radius or CA is perpendicular to this plane. CA is normal to this plane. Therefore, direction ratios in preliminaries we have seen, direction ratios of CA are what? 2 minus 2, 1. These are the direction ratios of CA. Coefficients of XYZ 2, -2, 1 are the direction ratios of this segment CA. And direction ratios of the line CA or segment CA are known to you. One of the point is known to you. Then equation of CA you can write. Equation of CA, how do you write? X minus 1. In preliminaries this we have seen. Y minus 2 and Z minus this. And the direction ratios of CA I have to write. What are the direction ratios? 2, -2, 1. X minus A by L, Y minus B by M, Z minus C by N. In preliminaries that we have seen. So this is equation of line CA or segment CA you can say. The X minus 1 by 2 all are the ratios, and for the sake of simplification I am going to equate those ratios with the constant K or lambda whatever. Now here first ratio I am equating with K, second ratio I am equating with K, and third ratio I am equating with K. The value of X minus 1 is have a cross multiplication. Here have a cross multiplication. Here also the cross multiplication. Z, 1 I am shifting on the right hand side. Y is equal to -2K plus 2. This 2 I have shifted on the right hand side. This 1 I am shifting on the right hand side like this. The values of XYZ we have obtained. XYZ be the coordinates of any point on the line. But we are interested in the coordinates of A. One of the basic fact we are going to use. Okay, which basic fact we are going to use? See, this point lies on this plane. Point A lies on the plane, and equation of plane is given to you. 2x minus 2y plus z plus 12 equal to 0. This point A lies on the plane. Therefore, this point will satisfy the plane. Means what to do? To put x equal to value of x, y equal to value of y, z equals the value of z plus 12 equal to 0. Yes, what is x? X is 2k plus 1 in terms of k. Minus 2k minus 2k plus 2. This is k minus 1. And if you solve it, this is 4k plus 2 plus 4k minus 4, k minus 1 plus 12 equal to 0. 4k plus this is 9k. 2 minus 2 is minus 3 plus 9 equal to 0. 9k equal to minus 9. This implies k equal to minus 1. The value of k we have obtained. But this value of k is conditionally. The value of k we have obtained when this point A lies on this plane. At which position point A lies on the plane? At this position. Point A lies on the plane. Therefore, coordinates of the point will be what? Coordinates of A, 2k plus 1 minus 2k plus 2, xyz coordinates of. But these are the coordinates of A for k equal to minus 1. So put k equal to minus 1 here. If you put k equal to minus 1, what will happen? K equal to minus 1, k equal to minus 1. Is it? Then minus 2 plus 1 is minus 1. K is minus 1. This is 4. 2 plus 2, and this is minus 2. Okay, this is the point of contact of the sphere and the plane. Now the next problem. Find the equation of sphere tangential to the plane. I want equation of the sphere. This sphere is tangential to the plane 2x minus 2y minus z plus 16 equal to 0. At the point minus 3, 4, 2. Here point of contact is given. in previous problem, we found point of contact. Here point of contact is given. And the same sphere, this required sphere, passing through the point -203. Find the equation of the sphere tangential to the plane. The sphere is tangential to this plane. At this point of contact of the plane and the sphere is given, and the required sphere passing through the point -203. What we want, we have to find out equation of the sphere. Yes, for equation of sphere, the two things are required: the radius of the sphere and the center of the sphere. If center is known to you, by distance formula you can find out radius of the sphere. And the center is known and the radius is known, so you can find out center radius from formula and you can get the equation of the sphere. This CA is normal to the plane. The direction ratios 2 -2 -1. And one of the point on this line is known to you. This point A lies on the line, point A lies on the plane also. But one of the point on the line CA is known to you. Therefore, equation of CA, how do you get? X minus of 3 by direction ratio, y minus 4 by second direction ratio, and z minus 2 by third direction ratio. The same thing we have done in the previous problem also. The x plus 3 by 2 first ratio, y minus 4 by -2 second ratio, z minus 2 by -1 third ratio, and this I am equating with proportionality constant. Now here I will get values of x, y, z. X plus 3 by 2 is equal to k, y minus 4 by -2 equals k, z minus 2 by -1 equal to k. Therefore x equal to 2k minus 3, y equals minus 2k plus 4, and z equals minus k plus 1. And these values of x, y, z we have obtained. And values of x, y, z are the coordinates of any point on C. This values of x, y, z, 2k minus 3, minus 2k plus 4, coordinates of any point on C. So what I want coordinates of C, which is the center of the sphere. In last problem, we found coordinates of A. Now here, we are going to find out coordinates of C. What are the coordinates of C? Coordinates of C, here I am writing 2k minus 3, comma, minus 2k plus 4, comma, minus k plus 2. These are the coordinates of this point. You can find out the distance between these two. And the perpendicular distance between these two you can easily find out. The CQ is the radius of the sphere. CA is also radius of the sphere. Can I write CQ equals CA? Both are radii of the sphere, CQ and CA, and they are same. So by distance formula, how do you find? 2k minus 3 minus 2 whole square, 2k minus 3 minus 2 square plus minus 2k by distance formula, minus 0 whole square plus minus k plus 2 minus 3 whole square. Okay, this is the root, 2k minus 3 minus of minus 3, directly writing. Minus 2k plus 4 minus of minus 4 is minus 2k whole square. Minus k plus 2 minus of minus 2 is minus k whole square. Now, you can take the square of it, square of both the sides. The root will disappear and try to find out the value of k then. The value of k is 1. And once you get the value of k, then put value of k here. Therefore, the coordinates of C, 2k minus 1, 2k minus 3, 2k minus 3, minus 2k plus 4 and minus k plus 2. The put value of k here, that's all. Then this is minus 1, this is 2 and this is 1. Okay, these are the center of the sphere. These are the coordinates of C. Coordinates of C. And once you get center and the radius, you can get the equation of the sphere. And what is it? Radius of the sphere here? Okay, this CA is radius of the sphere. This I am writing here. This is 2k square, 2k square and k square. This is 9k square, And here k is 1. Is it? And under root of 9 is like this. Okay. And radius is 3. This is radius. Radius is 3 and center is this one. Then equation of sphere you can write. Equation of sphere x minus of this whole square center radius form equal to radius square. Radius is 3. So this is equation of sphere where the point of contact is given, equation of plane is given, and one more additional thing is given, that required sphere passes through the point minus 2, 0, 3.
Next problem. Here, this is short answer question. Radius of the circle formed by the intersection of sphere and the plane is asked. In offline examination, if it is not given, center and radius of the sphere is not given, you can find out radius and center of the sphere from this equation. But here, center and radius is given to you. The center of the sphere is 1 minus 2 minus 1. The radius of the sphere, okay, this is the radius of sphere now. Cm is given to you, which is radius of the sphere, and this is not known to us. If Cp is known to us, then using Pythagoras theorem, we can find out value of Pm, which is radius of the circle, and circle is the intersection of the sphere and the plane. We can find out the equation of plane is given. What is the equation of plane? X plus 2y plus 2z minus 4 equals 0. And this is the perpendicular from center of the sphere C to the plane. The perpendicular distance formula we can use is, what is perpendicular distance formula? The perpendicular distance formula many times we use. Here 1 multiplied by 1 is minus 2 multiplied by 2 minus 1 multiplied by 2 minus of this 4 minus of this 4 ax1 plus by1 plus cz1 plus d. Okay, this is plus, Now under root of a square plus b square plus c square means 1 square 2 square plus 2 square. Now this perpendicular distance, this is 1 minus 4 is minus 3 minus 3 minus 5 and this is minus 9. This is under root of 9. Therefore, this Cp equals 9 by root 9 is 9 by 3. This mod of minus 3 and Cp is a distance which is positive. This is 3. The Cp we found, which is 3. Now, by Pythagoras theorem, you can find out value of Pm. I am using Pythagoras theorem in this right angle triangle PCM. Here Cm square hypotenuse square plus Cp square plus Pm square. Cm is root 12 plus Cp square CP is, just we found CP is 3, and PM I want. PM is radius of the circle. Then this is 12 minus 9, which is PM square. 12 minus 9 is 3 PM square. And if I take square root of this, it will be plus minus under root of 3. But PM is the radius which is always positive, radius of the circle which is always positive. The value of PM is root 3. And this PM is radius of the circle. Now, the next problem. Find equation of sphere through this circle, and the sphere passes through the point 1 minus 2, 3. Equation of the sphere is passing through this circle. This equation of the circle is not directly given. Circle is the intersection of this sphere and the plane, and the required sphere passes through this point. Here the situation is like this. This sphere is given to you. Equation of sphere and the plane, these two are going to intersect with each other, and intersection of sphere and the plane is a circle, and we want equation of sphere which passes through this circle. I want equation of the sphere which passes through the circle means this circle is lying on the sphere, required sphere. This sphere may be like this. Sphere may be like this. Sphere passes through this circle, and the sphere passes through this point also. This one point on the sphere is already given to you. The required sphere is passing through this circle, and circle is the intersection of this sphere and the plane. Then equation of required sphere I am writing in this way: S plus KU equals 0. Here U represents the plane and S represents the sphere. What is S? Sphere, equation of sphere is given to you. This is given. Then equation of plane is also given to you. X minus 2y plus 4z minus of 9 equals 0. So this is the equation of required sphere. Now it remains to find out value of K. So once you get the value of K, then we will get equation of required sphere. But what is additional thing given? This sphere passes through the point 1 minus 2, 3. This point is lying on this one, on the surface of the sphere, or this sphere passes through this point, means this equation of the sphere is being satisfied by this point. Since this sphere passes through this point, sphere passes through the point 1 minus 2, 3. So what to do? Put x equal to 1, y equals minus 2, and z equal to 3. Because this equation is being satisfied by this one. So I am putting x equal to 1, y is minus 2, z is 3, x is 1, y is minus 2, plus k times x is 1, y is minus 2, and z is 3, minus 9 is also there, equal to 0. Now try to simplify and get the value of p. This is 1 plus 4 is 5, 5 plus 9 is 14, 14, 16, 16, 10, and this is 16 now. 16 plus k multiplied by this 12 minus 9 is 3, 3 plus 5 is 8, and this implies k equals minus 2. The putting value of k here in this equation, therefore equation of required sphere will be what? X square plus y square plus z square plus 2x plus 3y plus 6, and value of k is minus 2, x minus 2y plus 4z minus 9 equals 0. So you may solve it for one more step. Means you can have the multiplication and then add the terms of x, y and constant. So that is for you. So the next part. What are the orthogonal spheres? When two spheres are said to be orthogonal, if angle between their tangent plane at the point of intersection is 90 degree. Means if tangent planes are perpendicular, then we can say those spheres are orthogonal to each other. Here in this figure, this is the first sphere, this is second sphere. Equation of first sphere is this one, equation of second sphere is this one, and this is the point of intersection of two spheres. These are the centers of the spheres. If I join these 3 points, then you will get right angle triangle. Then by Pythagoras theorem you can write like this: the C1 C2 square plus R1 square plus R2 square. This square of the distance between C1 and C2 is equal to sum of the squares of radii. Now in this problem we are going to check whether these two spheres are orthogonal or not. This sphere is this one and equation of this sphere is this one. The x square plus y square plus z square plus 6y plus 4, this is equation of sphere. And when equation of spheres are given to you, then a condition of orthogonality we are going to use. The condition of orthogonality I am going to write. What is condition of orthogonality? This 2u1 u2 plus 2v1 v2 plus 2w1 w2 equals d1 plus d2. Okay, S1 is a sphere and S1 is x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 equals 0. Okay, this is the first equation of the sphere, and second equation of the sphere, x square plus y square plus z square 2v1 2u2x 2v2y 2w2z plus d2 equals. This is d2. Now these two spheres are orthogonal to each other, then this condition is satisfied, or if this condition holds, then we can say these two spheres are orthogonal to each other. The u1, v1, u2, v2, w1, w2, d1 and d2, all those values I will get from here, from equation of sphere. And these are the general equation of the sphere. Here two spheres are given. From the first sphere I am going to find out value of u1, v1 and w1, d1. See, coefficient of x is 2u, which is not here means 0. This implies the u equals 0. Coefficient of y is 6. V is equal to 3. Coefficient of z is 2w and the z term is absent. So this is w equals 0. But here we have two spheres. Therefore u1 v1, u2 v2 and w1 w2 I will be using. And here d1 is what? d1 is 4. Now for the second sphere, x square plus y square plus z square plus 6x plus 8y plus 4z plus 20. Let's find values of u, v, w and d. Here 2u2 is coefficient of x, 2v2 is coefficient of y and 2w2 coefficient of z, and the constant coefficient is what? 20. So this means u2 is 6 by 2, v2 is 8 by 2, w2 is 4 by 2 and d is this one. Okay, and I am calling this as d2. for convenience because we are going to use this formula. Now I am going to check whether this condition of orthogonality is being satisfied all values of UV, W and D. So you take left hand side. If I write left hand side 2U1, U2, 2V1, V2, 2W1, W2, and putting values of this is U1 is 0, U2 is 3, V1 is 3, V2 is 4, W1 is 0. Okay, this is W1, V1 and W2. It is 0 and W2 is 2. And this is coming to be, this is 0, this is 0, this is 12 and 20. Now take right hand side, D1 plus D2 is the right hand side. D1 is 4 and D2 is 20 and it is again 24. Means this is equal to D1 plus D2. This condition is being satisfied. Therefore, given spheres are orthogonal to each other. These two spheres are orthogonal to each other. In this way, we can check if this condition is not satisfied, then we cannot say these two given spheres are orthogonal to each other. We stop here. Thank you very much.